కాదు కాదు ఆ అబ్బాయిది కాదు. నన్ను ఇది చేశాను ఇంతే కదా. అదే ఇది చేశాను కదా, ఇది పెట్టాను. అవుతుంది స్ట్రింగ్. ఆ లింక్ నీ దగ్గర కూడా ఉంది కదా. ఇప్పుడు లింక్ మారిపోతేమో కదా.
అంటే ఛానల్లోకి వెళ్తే
వచ్చేస్తుంది.
కొత్త లింక్ షేర్ చేస్తాను. లైవ్ వచ్చింది.
ఉంది అది వచ్చింది. వచ్చింది ఆ లింక్ వచ్చింది. ఆ లింక్ టెక్స్ట్లోకి రాలేదండి నాకు. కాపీ లింక్ నేను షేర్ లింక్ కొట్టాను. స్పీడ్ తినేసి వచ్చేసావా?
అంటే ఇంటికి
ఎక్కడికి?
మా ఇల్లు ఎక్కడ సార్? చలమీపేట.
ఇక్కడ చలమీపేట ఒక బోర్డు ఉంటుంది.
అదే సార్.
ఓకే. మరి బయటికి వెళ్ళానన్నారు తినడానికి?
అంటే మళ్ళీ అంటే ఎలాగైనా తినడానికి వెళ్ళాం కదా, మళ్ళీ మొత్తం ఏం చెప్తాను వచ్చేసాను కదా.
నేను మీరు మామూలు ఫ్రెండ్స్ బాగా వెళ్ళారేమో.
అంటే ఈరోజు ఈవెంట్ అవుతుంది కదా ఆవిష్కర్ది.
ఆవిష్కర్ నిన్న అయిపోయింది కదా.
అంటే 24 hours హ్యాకథాన్ కదా సార్.
ఇంకా అవుతుంది.
మార్నింగ్ 9-10 క్లోజ్ చేశారు. ఇప్పుడు డ్యూరీ అవుతుంది.
ఓకే. ఈ 2 days క్లోజ్ అది.
ఈ రోజుతో అయిపోతుంది. విజువల్ రౌండ్ మళ్ళీ నెక్స్ట్ మంత్
ఇక్కడ ఉంటుంది. ఇది సెల్ఫ్ ఫిజికల్.
ఇక్కడ టాప్ 15 ఇస్తారు సార్. దానిలో టాప్ 10 మాత్రమే సెలెక్ట్ చేస్తారు. అంటే వాళ్ళు ఖచ్చితంగా ఫిజికల్ ప్రోడక్ట్స్ మళ్ళీ సపరేట్ ప్రాబ్లమ్ స్టేట్మెంట్స్.
ఇవి ఎవరు వేస్తున్నారు ప్రాబ్లమ్ స్టేట్మెంట్స్?
అంటే వంశీ సార్ ఏమో కోఆర్డినేట్ చేస్తున్నారు. చాలా 25 ఫీట్ చూపిస్తారు. ఫస్ట్ ఇన్ ఫస్ట్ అవుట్ సార్. ఒక ప్రాబ్లమ్ స్టేట్మెంట్ 10 members తీసుకోవచ్చు అన్నమాట.
ఏదైనా సెలెక్ట్
చేసుకోవచ్చు. అంటే వాళ్ళు దీన్ని బట్టి అన్ని బ్రాంచ్కి కట్టామండి. ఒకటి 10 members మాత్రం సెలెక్ట్ చేసుకోవచ్చు. ఫస్ట్ ఇన్ ఫస్ట్ అవుట్.
మరి 10 members మీకు ఎలా తెలుస్తుంది?
మేము అంటే వెబ్సైట్లో ఇచ్చినప్పుడు 10 members ఆప్షన్ డిసేబుల్ అయిపోతుంది.
ఎవరు చేశారు అది వెబ్సైట్?
వెబ్సైట్ స్టూడెంట్స్ సార్. ప్రశాంత్ అంటే స్టూడెంట్స్ భార్గవ్ సార్ ఇంకా సతీష్ సార్
స్టేట్మెంట్ అన్ని ఏరియాస్లో ఉన్నట్టుంది.
నేను నైట్ మెంటర్ సెషన్ మెంటర్స్ బయట అంటే
ఇండస్ట్రీ
మొత్తం అందరూ బయట సార్. మెంటర్స్ మన అల్యూమినియం కొంతమంది ఉంటారు. 16 members సార్ మొత్తం. ఒక ఇద్దరు భార్గవ్ సార్ సతీష్ సార్ ఇద్దరు.
అల్యూమినియం ఉన్నారు కదా. తినే అల్యూమినియం తిన్నాడు. అట్లీస్ట్ స్టూడెంట్స్ ఎక్కడో దగ్గర లర్నింగ్ స్టేజ్ అనేది వస్తుంది. శాఖలోనే ఉంటావు కదా,
ఇస్తాను.
ఏదైనా అయితే ఇమీడియట్గా నీకు ఫోన్
ఓకే
చేస్తాను.
కిందనే ఉంది.
అది నువ్వు ఆల్రెడీ నేను అంతా సెట్ చేసేసాను కదా, అందుకే స్ట్రీమింగ్లోకి వెళ్ళగానే బై డిఫాల్ట్ తీసేసుకుంది అది.
నేను అదే పెట్టాను, ఆప్షన్ కూడా పెట్టాను ప్రీవ్యూ సెట్టింగ్స్.
అవును, అదే అందువల్ల అది అదే అందులో అలా నువ్వు చేసి ఇది ఈ స్క్రీన్ ఇది మొత్తం తీసుకున్నది కదా, ఈ స్క్రీన్ సైజ్ మనం తగ్గించగలమా? ఇది ఇప్పుడు ఇది మొత్తం విండో మొత్తం క్యాప్చర్ అవుతుంది. మళ్ళీ తెలియదు మళ్ళీ
అది అంటే మీరు చిన్నది చేసినా మీకు చిన్నదైనా ఎంత స్క్రీన్ కనిపిస్తుంది సార్ దీనిలో నాకు తెలిసి. అంటే మనం ఈ ట్యాబ్ తీసుకున్నాం ఇంకా సపరేట్గా క్రోమ్.
అవును, యాక్చువల్గా మనం విండో సెలెక్ట్ చేసుకున్నాం కాబట్టి టోటల్ విండో వస్తుంది.
ఇది మీరు అసలు చిన్నది చేసినా
అవును
ఇది ఎంత కనిపిస్తుంది.
అవును, ఇందులో ఇది ఎలా ఉందో అక్కడ అదే అలానే తీసుకున్నాం. అవును, ఇక ఇక్కడ నీకు అక్కడ మార్పు, ఎందుకంటే ఇదే కదా మనం క్యాప్చర్ చేసింది.
ఇక్కడ మనం అంటే నార్మల్గా స్ట్రీమింగ్ యూజ్ చేసినప్పుడు అయితే ఇక్కడ నార్మల్గా ఏమైనా యాడ్స్ ప్లే చేయాలంటే ఇక్కడ ప్లే
అవును, వీటి పక్క నుంచి అది చేసుకోవడం
అంటే ఆప్షన్ అందుకే యూజ్ చేస్తాం.
అవును, ఇందాక మనకి మొన్న చార్ట్ అని వచ్చింది కదా, అది కావాలంటే పక్కన మనం పెట్టుకోవచ్చు. అక్కడ
కింద కామెంట్స్ పెట్టేసుకోవచ్చు.
అడ్వర్టైజ్మెంట్స్ రన్నింగ్ గట్రా కింద రన్ చేసుకోవచ్చు కదా. ఇప్పుడు యాక్చువల్గా మూవీస్లో గట్రా అదే కదా, ఈ బ్యానర్ ఎక్కడికి ఈ బ్యానర్ రన్ అవుతుంటుంది, ఈ సైడ్ అడ్వర్టైజ్ సైడ్స్ రన్ అవుతుంది. ఇప్పుడు దీని ఆన్ స్క్రీన్ మీదకి ఏమైనా కావాలంటే దీని మీద యాడ్ తీసుకొచ్చి పెడతారు. ఇది ఈ మైక్ మన QPS నుంచి రీడ్ చేస్తుంది కదా వాయిస్.
వస్తుంది సార్ ఒకసారి దీనికి సంబంధం లేదు. దీని మీటింగ్లో మైక్లో ఆప్షన్స్ మూడు ఉంటుంది.
అవును, ఇది ఆఫ్లో ఉంది కదా.
ఒకసారి ఒక్కడే ఆన్ కావాలి, మైక్రోఫోన్ ఉంది కదా,
అవును
అది నొక్కితే అక్కడ 3 వస్తుంది సార్. నొక్కండి PR మైక్ నార్మల్ వచ్చి సౌండ్ అయిపోతుంది. అదైతే సాంగ్ ఉంది.
ఇదంతా కాపీ చేసేది డిఫరెంట్ కాపీస్ నుంచి. విష్ణుప్రియ అయిపోయిందా? ఒకసారి వస్తుంది కిందికి వస్తుంది. నేను ఏదైనా ఉంటే ఇమ్మీడియట్గా నీకు కాల్ చేస్తాను. అవసరం సరే ఇటువైపు విఠల్ సార్ చెప్పండి. అవును, ఆయన జాయిన్ అయ్యి ఉన్నారు. అది చెప్పి కో హోస్ట్ ఇచ్చాను. 10 minutes స్టార్ట్ చేద్దాం. 2కి అనుకున్నాం కదా. 2 ఓకే సార్. మేడం రెడీగానే ఉన్నారు కదా. అదే మీకు కో హోస్ట్ ఇచ్చాను, ఆయనకి కో హోస్ట్ ఇచ్చాను. మీరు ఒకసారి అతను వచ్చారు ఆల్రెడీ. అవునండి, అతను వచ్చారు. మీరు ఒకసారి కనెక్ట్ అయ్యి సార్కి వెల్కమ్ అదే గుడ్ ఆఫ్టర్నూన్ చెప్పేసి సార్ షాల్ వి స్టార్ట్ అని చెప్పి అడిగేసి ఓకే అంటే అప్పుడు మీరు స్టార్ట్ చేయండి. ఓకేనా?
Good afternoon, sir.
Good afternoon, madam. May I
Shall I start it, sir?
Yes, madam.
Okay. Good afternoon, distinguished guests, faculty members, and participants of our 5-day online faculty development program on quantum computing and machine learning, bridging quantum theory and intelligent systems. So this is the day 3. So it is my privilege and honor to introduce our esteemed speaker for this session, Dr. Salkapuri Rakesh. Dr. Rakesh Salkapuri is a senior assistant professor in the Department of Artificial Intelligence and Machine Learning at Symbiosis Institute of Technology, Hyderabad campus, Symbiosis International Deemed University in Pune. He holds a PhD in Computer Science and Engineering and MTech in Software Engineering and BTech in CSC, bringing over 14 years of academic and research experience. His expertise spans artificial intelligence, computer vision, and bioinformatics, and he is a recognized PhD supervisor at Symbiosis International University. Dr. Salkapuri has published 30 plus research papers in reputed Scopus, Web of Science, and SCI Index journals, including prestigious publishers such as IEEE, Springer, Elsevier. He has made significant innovative contributions through multiple patents, including AI-driven systems for cardiovascular and Parkinson's disease detection, deep learning models for melanoma classification, IoT blockchain-enabled smart home solutions, and CNN-based sign language recognition. A dedicated academic leader, he is an active member of IEEE, SCRS, IST, and IAENG, and frequently serves as a keynote speaker, reviewer, and session chair in international conferences and journals. As a coding club coordinator at SIT Hyderabad, he drives technical excellence by organizing hackathons, coding contests, workshops, and mentoring students in competitive programming, open source development, and real world project building, helping them excel in research, internships, and innovations. Ladies and gentlemen, please join me in extend a very warm welcome to Dr. Salkapuri Rakesh. We are honored to have you with us today and look forward to your talk, which we are confident will deepen our understanding and spark new ideas for teaching and research in this exciting domain. Sir, over to you.
Yes. Thank you very much for introducing me. Am I audible?
Oh. Yes, sir.
Yes. So I'm going to share my screen. I hope my screen is visible and PPT is in presentation mode. Madam?
Yes, sir. Yes, sir. Your screen is visible, sir. Carry on.
Okay, thank you, sir. So, good afternoon, everyone. So, welcome again to day 3 of the national level online faculty development program on quantum computing and machine learning, bridging quantum theory and intelligent systems. So, myself, Dr. Rakesh Salakapuri, currently working with Symbiosis Institute of Technology, Hyderabad campus, Symbiosis International University, Pune, India. So today's session focuses on machine learning foundations, a key prerequisite for understanding quantum machine learning, so which we will touch upon towards at the end of this session. Coming to the agenda, today's session agenda. So in this 1.5 hour, 2 hour session, probably I'm going to cover overview of classical machine learning, concepts and applications of classifiers like SVM, ANN, CNN, followed by feature extraction techniques and their importance, and model optimization techniques and their importance, and evaluation metrics, the importance of getting evaluation metrics, and challenges and limitations of the classical ML models. These theory concepts I'm going to cover, followed by I'm going to explain hands-on supervised machine learning techniques, some classification, some regression techniques I'm going to explain. Then at the end of the session, going to give a gist of in introduction to quantum machine learning. So this is the agenda of today's session and the objectives of this session. So usually in each class, I will try to explain what are the objectives of the class, and at the end the participants are going to get these outcomes. So the objectives of this today's session are, so majorly you are going to understand the core concepts and terminology of classical machine learning technique, and you are going to apply these machine learning techniques in Python using scikit-learn, including pre-processing, model training and evaluation. And you're going to train and evaluate ML models on real data sets. And also you're going to evaluate the model performance using standard metrics. And you're going to get a small awareness of quantum machine learning and its significance, and what are the current research opportunities. So these are the session objectives. So now moving to overview of classical machine learning. So what is machine learning? So how can we define machine learning? Most of you might know already, but anyway, so machine learning is all about enabling computers to learn patterns from data. Learn patterns and get some insights from the data without being explicitly programmed. So in this way we can define machine learning. So you can think of machine learning as, so like this, algorithms plus data plus experience. Together we call it as machine learning. So there are machine learning techniques majorly classified into 3 categories. Those are supervised machine learning, unsupervised machine learning, reinforcement learning. So in supervised machine learning, we are going to use labeled data. Whereas in unsupervised machine learning, we are going to use unlabeled data. And reinforcement learning, we are going to learning by getting some rewards. This concept we are going to implement in reinforcement learning. So machine learning techniques majorly classified into these three categories: supervised learning, unsupervised learning, and reinforcement learning. So coming to classical machine learning techniques. So the popular classical machine learning techniques include support vector machines, artificial neural networks, convolutional neural networks. So classical machine learning algorithms. Before deep learning revolutionized artificial intelligence, so these classical machine learning techniques were the mainstay. So these classical ML still extremely effective, especially when we working with structured data sets. Structured data sets like CSV data sets, Excel, sensor data, financial data, like this. When we are using these different data sets, still classical machine learning are most effective to use to gain good insights. So the key features, the key characteristics of these classical machine learning techniques include, so these techniques works well with structured and tabular data. As just now I said, so CSV data, Excel sheet data, sensor data, these data are structured and tabular data. So we can use these classical machine learning techniques. These techniques works well with this data. And these techniques, classical machine learning techniques, requires feature engineering, which I'm going to explain soon. So feature engineering means, so in the data set, we are going to consist many features. Out of all features, what are the important features we need to understand? We need to use only important feature. This concept is called as feature engineering. And these classical machine learnings works efficiently with small and medium data sets. When the data set is large, then applying these classical machine learning techniques is little difficult. That's why we are going to take the help of deep learning, especially for large data sets. So examples include, as discussed, support vector machine, artificial neural networks, decision trees, convolution neural networks, KNN classifiers. So all these and many more comes under these classical machine learning techniques. I hope I'm audible and clear, right? One of you please acknowledge in the chat. Yes, thank you, Kiran madam.
Yes, sir, you are audible. Hello?
Yes, sir. Yes, I'm continuing. Thank you. Thank you. So, till now, just now, I have introduced what is machine learning, what are the classical machine learning techniques, and machine learning categories: supervised learning, unsupervised learning, reinforcement learning. So, and what are the key features of machine learning? So now, classical ML versus deep learning. Anyway, today's session is mostly based on machine learning only, but I want to keep this in one single slide. So classical machine learning requires feature engineering. As discussed, it works with efficiently with small and medium data sets, and these machine learning will give results in faster way, faster training and easier explainability. When compared to deep learning must use large data sets, and especially if you want to get the results little quickly, then we have to use hardware GPU also for deep learning. So in current situation, most of the researchers or most of the institutes not having GPUs yet. So machine learning still many researchers are using widely. So moving to the first classical machine learning model, that is support vector machines. Support vector machines. So SVM is one of the most powerful classical ML technique. Its objective is to find optimal separating hyperplane. Optimal separating hyperplane that maximizes the margin between classes. So simple, these support vector machines majorly categorized into two categories. Those are linear support vector machines, non-linear support vector machines. Support vector machines, most of you already seen simple x-axis, y-axis diagram. The different data points, let us take plus data points and minus data points. Those if separable using single line, then that is called as linear, straight line boundary, linear support vector machine. Implementing that is so easy when compared to non-linear support vector machine. So these SVM works exceptionally well for high dimensional data and for problems where data is not too large but is complex. So there are different types of kernels we are going to use, especially linear kernel, polynomial kernel, and RBF kernel. So why we need to use kernel here? So this example, if you look at this diagram, here we have different data types. The data points which are green color and circle is one category, and the data points which are square and red color is another category. So by drawing single line and separating these data points is almost impossible. If you look at this diagram, so by drawing single line and separating these two is almost impossible. So that's where we are going to use non-linear SVMs here. In this case, we are going to use non-linear support vector machines. So non-linear support vector machines, what they will do? So they will convert the given data points into high dimensional data like this. Converts into high dimensional data so that we can draw a hyperplane like this rectangle to separate these data points. So in this way, non-linear support vector machines are going to widely used in many of the applications. So this is the best example we can take to understand about the non-linear support vector machine, especially the kernel tree. So in nonlinear, most of the nonlinear support vector machines, the given input data points, we are going to convert into high dimensional data points. So that by drawing hyperplane, it is possible to classify almost exactly. We are going to get accuracies more than 90%, I can say. So the kernel trick helps SVM classify complex data without explicitly computing high dimensional transforms. Generally, linear kernel we are going to use for roughly linear data. Polynomial kernel we are going to use for curved decision boundaries. Sometimes we can draw some curved lines to separate the data points. In such cases, we are going to use polynomial kernels. And RBF kernel we are going to use for overlapping classes. Most of the real-time data sets may have overlapping classes. So RBF kernel is widely used classifier technique, kernel technique. So this is how support vector machine we are going to use to classify the given data. So what are the advantages and applications of support vector machines? So the advantages of support vector machine model is, so it is effective in high dimensional spaces, works with nonlinear data using kernels, and it is robust against overfitting. So overfitting problem we are not going to get by using this SVM classifier. And applications. So the SVM applications not limited to this. So some of the applications only I have included here. So in cancer detection, we are going to use SVM classifier. In face recognition application, we are going to use, and handwriting recognition application we are going to use, and in bioinformatics. In lot of healthcare projects, we are going to use still this classical SVM application. So I can say it remains a top choice for high dimensional data, work with large bioinformatics datasets. So this is about support vector mission. I hope you understood support vector mission. So moving forward, artificial neural networks, ANN classifier. So artificial neural networks mimic the structure of the human brain. I can say it is going to mimic the structure of human brain. So that means, so like how human brain thinks, even these artificial neural networks also we have trained in such a way, similar way. So they consist of mainly input layer, hidden layer, and output layer. So the basic architecture of ANN is shown here: input layer, hidden layer, and output layer. All these layers are interconnected. So ANNs are suitable for medium complexity data and form the basis for modern deep learning. ANN is one of the key concepts behind introduction of deep learning concepts. So in artificial neural networks, we are going to use the concept called activation functions. So activation functions will give lot of power to the neural networks. So they allow the network to learn non-linear relationships and determine when neurons activate. So examples include, we are going to use the most commonly used activation functions are ReLU activation function, sigmoid activation function, and TANH activation function. So these learn complex data patterns and perform classification, decide which neuron should activate, and control gradient flow during the backpropagation. These are the key features of activation functions. And the most commonly used activation function and their range and their best place to use and why these are useful here. You can understand. So sigmoid activation function, the range of values include 0 to 1. So this sigmoid activation function we are going to use in output layer, and especially it is going to use for binary classification. When we are performing classification for true or false, say for example, binary classification, in that cases we are going to use sigmoid activation function. So it is going to give the probability. Similarly, the second activation function here is ReLU activation function. The range of values which consisted by ReLU activation function are 0 to infinity. So hidden layers of the deep neural networks. So here best place where we are going to use this ReLU activation function means in hidden layers of the ANN classifier. And these ReLU activation fast training and solves vanishing gradient. That's why we are going to use this ReLU activation function. Next, moving to the next activation function, that is TANH activation function. The range of values include -1 to +1. Even this TANH function also we are going to use in hidden layers. And we are going to use normalized data in TANH activation function. So this TANH activation function better than sigmoid function when we are going to use this normalized data. Similarly, we are going to use softmax activation function. The range of values of the softmax activation functions are 0 to 1 and sum is 1 here. You need to understand this part. Then this softmax activation function we are going to use in output layer. And this softmax activation function we are going to use especially with multi-class classification. So remaining activation function we are going to use in binary class classification. Binary class classification means only true or false, two only, 0 or 1. Whereas multi-class classification means whenever we are going to apply this classification model to get the results more than 2. So if you take cancerous, we are going to have different cancerous, malignant cancerous, no cancer, pregnant cancer, like this. When we are going to classify more than 2, the results are more than 2, 0, 1, 2 and more. In such case, we are going to use softmax activation function. So these are the 4 activation functions popularly used in ANN models. Next, moving to the next important concept in ANN, that is back propagation. So try to look at the diagram of back propagation and what is back propagation actually. So this back propagation is the learning algorithm used in neural networks. So what it do mainly, it computes the error at the output and propagates it backward, so that by updating the weights to minimize the loss. After computing the error, the update is passed again backward. Then it will go through all these phases: network initiation, initialize network learning, compute output at each layer for each neuron, compute training error, update weights. Then we are going to find the error. Again, this error is giving back to get improvised error. That means always error we are going to optimize. Optimize means minimize the error. The goal is minimizing the error. So with the help of back propagation, by adjusting the weights, it is possible to optimize the error a lot. So that's where this back propagation concept is very, very useful. This back propagation ensures the network learns from mistakes. So this is the key takeaway here. So first time when you train the model, you may get more error. But this, if you repeat multiple times with the help of this back propagation technique, definitely after few iterations, you are going to get good results. So it ensures the network learns from mistakes. So there are many different kinds of ANN models. So some of the ANN models include feed-forward neural networks, multi-layer perceptrons, recurrent neural networks, autoencoders. Even currently GANs are more popular. Even for all these, now quantum also applying. Quantum autoencoders, quantum GANs are current research going. So what are the applications of these ANN classifiers? So simply I can say for most of the data sets, we are going to use all these classical machine learning models, SVM, ANN, CNN. All these models are useful for lot of data sets. So even these ANN applications include, some of the applications include here for disease prediction. In bioinformatics, we are going to use ANN models. Then even fraud detection, we are going to use in cyber security and banking sector. Then it is used in forecasting, weather forecasting, etc., and customer segmentation. So like this, several real-time applications, still ANNs can be applied. So moving to the next model, that is convolutional neural networks. Convolutional neural networks. I hope you are following. So till now I have explained two classical ML models. One is support vector machine and the second one is ANN. So support vector machine, just recap for 1-2 minutes. Mainly classified into two types: linear, non-linear. So linear support vector machine, we can classify the given data sets, data points by simply drawing a line. Whereas non-linear means the data points overlapping may be present. So to overcome from that overlapping, we are going to use non-linear SVMs, kernel tricks. So with the help of kernels, we are going to convert the given data points into high dimensional data points. So by converting the given data points into high dimensional data points, there is a chance to draw an hyperplane which can separate the given data points. In that way, we are going to perform classification. So that is how we are going to use support vector machine classifiers. Next, moving to ANN, artificial neural networks classifier. So in artificial neural networks, so the key concepts used in artificial neural networks are activation functions as well as backpropagation. So majorly used activation functions include tanh, ReLU, sigmoid, and softmax. Most of the activation function used for binary classification, whereas softmax is used for multi-class classification. Similarly, backpropagation. So after going through the steps, we are going to find the error of the model. Then we are going to send back this error to the starting phase. So that in that way, using multiple iterations, the model learns mistakes and optimize the error by adjusting the weights. So till now I have explained support vector machine as well as ANN. I hope you are following. One of you please acknowledge in the chat box. Yes, just I have opened the presentation, the meeting window. Now I will share the screen. So moving to the next classical ML model, that is convolutional neural networks. So these convolutional neural networks majorly used with image data. So these are automatically extract features. So they automatically extract features, textures, shapes, and high-level image features. So automatically means we are going to create the model, develop the model, so that the model going to extract all these features, image features. And the architecture of the convolutional neural networks include convolution layers, pooling layers, and fully connected layers. So this is the common base architecture. One input layer, one convolution layer, one pooling layer, fully connected layer, and output layer. Input, we are going to give the image as input. Then in the convolution, it is going to extract the features of the images. Then it will pass through pooling, fully connected layer, and finally in the output we are going to get the classification result. So most widely commonly used example is, so given an image of cat or dog, then the convolution neural network model is going to classify. If you give the cat image, it is going to classify as cat image. If you give the dog image, it is going to classify the image as dog image. So this is the common CNN architecture. Nowadays, we have so many convolutional neural networks architecture. That means we have flexibility to develop our own CNN model by select layers we need, how many pooling layers we need, etc. So in that way, by changing these models for the different data sets, we are going to get good results. Again, these CNN applications. CNN is also widely used in lot of applications. Majorly in medical image analysis, we are going to use, and in object detection, facial recognition, satellite image classification, handwritten digit recognition. So like this, in many of the applications, this CNN model we are going to use. So now moving to the next important concept, that is feature extraction. Feature extraction. So this feature extraction transforms raw data into meaningful features. These classical ML models, till now whatever classical ML models generally does not understand raw images and raw text whatever you give. So there is a need to convert this into useful data. So we must convert them into numeric representations. So the reason why this feature extraction plays a key role in implementing these ML techniques. So these feature extraction techniques helps ML models focus on the most important patterns instead of all raw data. So why this feature extraction is needed? So classical machine learning models cannot directly understand images or audio or text. So the reason why we need to convert the given images or audio or text into machine learning model understandable way. For that purpose, we are going to use the technique called feature extraction. So this feature extraction is going to convert the raw data into numeric features. In that way, it is going to improve the model performance as well as accuracy and reduces dimensionality. So reduces dimensionality means, in the beginning also I said, so our data sets may consist multiple features. Among the features, some features may be useful, some features may be not useful. So here feature extraction key role is it need to get only the useful features from the entire features list. That technique is called as feature extraction. So the key idea here is from raw data get meaningful features so that better learning can be happen. And these feature extraction techniques for different types of data, different techniques exist actually. So for numerical data sets, we are going to use standardization, normalization, PCA, dimensionality reduction techniques. These techniques are popular to use with numerical data. Next, for image data, we are going to use edge detection techniques like Canny edge detection technique, Sobel edge detection technique, and histogram of oriented gradients, HOG techniques we are going to use for image data set, as well as LBP techniques we are going to use. Similarly, for text data sets, we are going to use bag of words, TF-IDF, word embeddings. These are the popular feature extraction techniques we are going to use. Similarly, for audio data sets, we are going to use MFCC feature extraction techniques. So these are really very helpful in performing lot of research. So I can give one example. So these Sobel and Canny edge detection techniques. So I have applied this Canny edge detection technique results to find the traffic at traffic light junction. So using these Canny edge detection techniques, I'm going to apply this technique to the vehicles present at traffic light junction. So that if you apply this Canny edge detection, more edges will come when more vehicles are there. So if more vehicles are there, then we need to give, say for example, to develop dynamic traffic management system, to the side where we have more traffic, that side we need to give little more green time. Instead of giving 30 seconds, we have to give 60 seconds. In that way, we are going to use effectively the traffic light junction. So like this, we have several applications. If you understand these basic concepts, then you are going to understand where we can apply these in real time. Each and every technique is going to widely used in many real-time applications we are going to use. So what are the feature extraction techniques benefits? So from the given raw data, it is going to get the meaningful data. The main benefit is that converts unstructured data into structured numerical format. By converting in this way, it makes model training more stable and efficient and improves the performance and accuracy and reduces the error. So helps in tasks like classification, clustering, detection and recognition. These are the benefits of this feature extraction techniques. And real world example. So some of the examples I have included here in presentation. In face recognition techniques, we are going to use face recognition means image data set. So we are going to use HOG, LBP, CNN features. In medical imaging, we are going to use extract tumor texture and shape features by using these feature extraction techniques. In speech recognition, we are going to build models on MFCC features. So this is speech recognition means audio data set. So we are going to use MFCC features. And in natural language processing applications, we use word embeddings for sentiment analysis. So like this, we have several techniques with these feature extraction applications. Moving to the next concept, that is model optimization techniques. Model optimization techniques. So what do you mean by optimization? So optimization means in general minimizing or maximizing. So with respect to the parameter based on understanding, we are going to minimize or maximize. Simply profit we need to maximize, loss we need to minimize. So similarly in classical ML techniques, so model optimization techniques plays a vital role in optimizing accuracy. Accuracy means we need to maximize the accuracy. And error, we need to minimize the error. Similarly, we have a lot of performance evaluation metrics like recall, precision, FL score, Z score, etc. So for different models, different data sets, we are going to use these different performance evaluation metrics. And some performance evaluation metrics we need to maximize and some metrics we need to minimize. So that maximizing and minimizing is possible by using these model optimization techniques. Model optimization techniques. So in this, especially, we have two types of parameters. So most of you already aware of this, hyperparameters and parameters. What are hyperparameters and what are normal parameters? So normal parameters are learned by the model simply, whereas hyperparameters used in configuring a model. Model configuration, we are going to use hyperparameters. So these are tuned manually or automatically. All techniques have automatic hyperparameters tuning facility, and if required, the researchers can tune these features manually also. So try to understand the comparison between these parameters and hyperparameters. So parameters learned automatically during training, whereas hyperparameters set before training. Examples include, the parameters include weights and biases. In ANN model we are going to use these concepts. Whereas support vectors in SVM we are going to use. Decision thresholds in decision trees we are going to use. These are the parameters. Whereas hyperparameters means learning rate. Generally, we represent with alpha constant. And number of layers, neurons, batch size, epochs, kernel type, tree depth. So based on the classifier used, we have different types of hyperparameters. These need to be set before training, automatically or manually, to optimize the model. By changing these parameters, by adjusting these parameters, we are going to improvise the performance of the models. So that's where this model optimization plays a vital role in improvising results, in applying these classical ML techniques to the real-time datasets. So these parameters, internal values updated by the algorithms. So these hyperparameters not learned by the algorithm. You have to remember this. Hyperparameters not going to learn with the help of algorithm, whereas parameters is going to learn the algorithm. Hyperparameters need to be set by the researcher. So these hyperparameters control how the model learns, whereas parameters determine the model's behavior. Is model working well or not well? Determined with the help of these parameters. And if any of the model not working well for the given hyperparameters, then if you change the hyperparameters values, definitely there is a possibility to improve the model. So why optimize hyperparameters? Till now I have explained. So what is the need of optimizing these hyperparameters? The major goal is to improve the model performance. So it ensures better accuracy, prevents underfitting and overfitting, improves training speed and stability, finds the best combination for model performance. So by adjusting the hyperparameter values randomly, we are going to get the best combination for what values, what type of values the model is going to perform well. So especially for performing this hyperparameter optimization, we have two techniques: grid search and random search. For performing hyperparameter optimization, we are going to have two techniques. Those are namely grid search and random search. So grid search, simply like a linear search technique. It will trace all possible combinations sequentially, and it is simple to implement, works well for small search spaces. But the major limitation is computationally expensive because it will perform linearly. So it is going to check all combinations to get the optimized result. Little more time is expected. So that's why the computationally expensive. Lot of time we need to spend working. Whereas if you go for random search, so random search randomly selects the combinations of hyperparameters. So what are the hyperparameters of a particular model? Say for example, learning rate, kernel tree. So those parameters randomly select some values. In this process, we are going to get the optimization results. There is a possibility a lot. Already it is proved. Random search much faster than grid search and often finds good results with fewer trials. Of course, it is purely based on luck, but we are training the model again and again. So in such a way, we are going to get, there is a chance that we are going to get the optimization results for the hyperparameters in few trials only. There is a possibility, definitely. So whenever high dimensional data spaces we are going to use, definitely we need to go with random search. If the data set is little low, then this grid search is preferable. So based on the data set you are going to use, you need to select the type of technique to perform hyperparameter optimization. Grid search or random search. Even next, we are going to use the concept like regularization. So we have two types of regularizations, L1, L2 regularizations. So L1 regularization, lasso regularization, L2 ridge regularization. So what is regularization actually? So regularization prevents overfitting by penalizing large weights. So it is going to prevent overfitting. So what do you mean by overfitting? So in general, overfitting occurs when a model memorizes training data but performs poorly on the test data. Instead of understanding, the model is going to memorize the training data so that on test data, whenever new data is given, it is unable to perform well. So this problem is called as overfitting. So to reduce overfitting, we are going to use this regularization concept, regularization technique. So L1 regularization, lasso regularization. So the key points in lasso regularization are: it adds penalty proportional to the weights. The key features include: it is going to add penalty proportional to the weights and shrinks some weights to 0. In that way, it is going to optimize. It is going to solve the overfitting problem. And in general, it is going to produce sparse models useful for feature selection technique. Lasso regularization technique is. Next, the second technique is ridge regularization technique. It adds penalty proportional to weight square. Try to understand the difference here. In lasso, we are going to add penalty proportional to weights, whereas in ridge regularization, the penalty proportional to weight square is added. It does not eliminate weights but makes them small and smooth. Lasso shrinks some weights to 0, but this ridge regularization does not eliminate weights. It's not going to shrink to 0, but makes them small and smooth. In that way, it is going to optimization. Helps the model generalize better way, used widely in neural networks and linear models. Ridge regularization concept. So how this regularization prevents overfitting? Simply by reducing model complexity, forces model to rely on important features, controls the weight magnitude, avoids memorizing training data. By controlling the weights, it avoids memorizing the training data. Just now I have explained. So if the training data, during the training phase, the model, if instead of understanding, if it memorizes, then definitely in testing phase, definitely lot of probability is there. Yeah, it is not going to perform well. That's where the overfitting problem will come. So to reduce this overfitting and to avoid overfitting occurrence, we are going to use majorly two types of regularization techniques: lasso regularization as well as ridge regularization. So this helps improve generalization on unseen data. By avoiding this memorizing, whenever new test data is given, so generalized, it will understand easily and gives good results. So overfitting problem and avoiding overfitting is an essential part of model optimization because it ensures the model generalization well to unseen data, improving true performance. Even cross validation technique we are going to use. Splits data into multiple folds, trains on some folds and validates on other folds. In that way, average performance reduces dependency on a single split. So this cross validation also helps improve model reliability and stability. So these are the techniques we are going to use for model optimization. Just before going to classification metrics, once again, just a quick review. What are the model optimization techniques? What is model optimization and what are the different techniques we are going to use to achieve good performance? I hope everybody listening and following, understanding. So a few more minutes I will explain theory, then we'll move on to hands-on session. So what are the different model optimization techniques? Just to revise quickly, we are going to understand a vital role in getting optimized results, good performance result. So how we are going to tune these hyperparameters? There are majorly two techniques we are having. The names of the techniques are grid search and random search. Grid search is a sequential approach. It will test for all possible combinations. So that's why more time may be taken. So computational cost is high if you go for grid search. Whereas random search, out of the combinations, some combinations it is going to select randomly, so that there is a chance that I am using the word I am highlighting. There is a chance that quickly we may get the better combination. So the reason why, especially whenever the data is large, high dimensional data is there, then instead of grid search, it is always suggested to go with random search. When the data is small, then grid search you can use for hyperparameter tuning. So not only hyperparameter tuning, for model optimization, we also use regularization concept, L1 regularization as well as L2 regularization. So these regularization, lasso regularization and ridge regularization, these perform weight adjustments. Then by performing weight adjustment, there is a possibility of getting optimized results. Then we need to avoid overfitting. Overfitting means during the training, instead of understanding the model, instead of understanding the features, it is going to memorize the features. If it memorizes the features, then it is difficult when you give unseen data, test data. There is a chance that the performance metrics are not sufficient. So definitely we need to avoid these overfitting. So these are the different model optimization techniques we need to apply when we work with real-time datasets. So moving to the next concept in continuation, that is classification matrix. So after applying model, the models are going to be tested or models are going to be evaluated on different data sets by finding some numerical metrics. So these metrics are called as classification metrics. So getting these classification metrics is very, very essential to publish our work, research work. So generally for classification metrics, finding accuracy is not enough. So along with accuracy, we need to find a lot of other parameters. Some of the parameters I have included in my presentation. So namely precision, recall, F1 score, confusion matrix. For getting deeper insights, we are going to use all these metrics. So classification problems require evaluation beyond accuracy. These metrics help understand these parameters: false positives, false negatives, true positives, true negatives, and model robustness. So the commonly used metrics, I don't want to spend much time, just quickly I will move forward. So accuracy, the formula for accuracy. Accuracy we are going to get when classes are balanced. So TP, TN, true positives, true negatives, FP, FN, false positives, false negatives. So confusion matrix, we can understand this easily. Then precision is one more classification metric. The formula for precision is this. So this precision important in scenarios where false positives are costly, especially in applications like spam detection, disease prediction. This metric is very, very useful. Next, moving to recall. The formula for recall is TP by TP plus FN. So this is important in situations where missing a positive is costly, especially in cancer detection application. We are going to use this. Next, moving to the next metric, that is F1 score. The formula is here 2 into precision into recall by precision plus recall. When we work with imbalanced data sets, F1 score you have to find.
Recording in progress.
So it is defined as harmonic mean of precision and recall. So this is an example of confusion matrix. So when you apply classical ML techniques on real-time data sets, so definitely you need to generate. You have to generate this confusion matrix, and from this confusion matrix, you are going to get all these metrics, performance evaluation matrix: accuracy, precision, recall, F1 score. So true positives. So these are actual positive and predicted results also positive. Then this is called as true positive. False negative. Actual positive, but predicted results are negative. So these are called as false negatives. Next, actual negative. These are actual negative, but predicted as positive. So these are called as false positives. And finally, the fourth one, these are actually negative, predicted as negative. So true negative. So diagonally, true positive, true negative. Actually positive, predicted as positive are called as true positive. Actually negative, predicted as negative are called as true negative. Whereas these two, false negative and false positive. False negative means actually positive but predicted as negative. Wrong. So false negative. Similarly, false positive. These are actually positive, actually negative, sorry, but predicted as positive. So these are called as false positive. So if you generate confusion matrix from these values, true positive, true negative, false negative, by applying these formulas, we are going to get all the classification metrics. And these classification metrics are helpful in understanding how the ML models work. And these are also helpful in comparing lot of ML models and different data sets. So if you are able to apply these models on different data sets and compare all the results, then definitely there is a possibility to produce a good research outcome. So performance evaluation metrics. So till now I have discussed with classification metrics, and one more important metric in the classification metric is AUC curve, area under curve. So generally the area under curve, if you get approximately near to the 1, then that model is good. If it is near to 0.5, then the model is not performing well. So whenever you are analyzing this AUC curve metric, higher AUC is better separability between classes. So here it is mainly useful for imbalanced data sets. So let us try to understand this threshold sensitivity. Just now I have taken example 0.5. So that threshold we have considered. The threshold value is 0.5 determine the classification. So changing the threshold changes the true positive rate as well as false positive rate. Again, like how you adjust hyperparameter tuning, here we can change this threshold value to improve your model. Next, moving to the next concept, that is regression metrics. So for classification, we have a set of metrics we need to find. Similarly, for regression task, we have some other set of metrics. So regression models predict continuous values. So that's why we are going to measure error to evaluate the model accuracy. And we are going to find the different errors. Again, so many metrics are there. So namely, MAE, mean absolute error, MSE, mean squared error, RMSE, roots mean squared error, R square score. So these are the different metrics we need to evaluate to understand the regression models. And the formulas are given here. Mean absolute error. Next, mean squared error formula. Average of squared errors. Mean squared error is average of squared errors. Next, root mean squared error. By applying root to the mean squared error, we are going to get root mean squared error value. And R square score. R square value, if you get 1, perfect fit. Near to 0 means not perfect. Sometimes there is a possibility of getting negative values worse than baseline. So we have seen classification metrics, then regression metrics, then moving to the next concept, that is image evaluation metrics. When we are performing different tasks on different data sets, again I am repeating. So when you are applying different models on different data sets, different performance evaluation metrics you need to evaluate. This is very, very essential in producing research outcome. So while performing image processing tasks like classification or segmentation, so we require different types of metrics again. So some of the metrics I have included again here for recap purpose, for understanding purpose. So for image reconstruction or segmentation or compression, finding accuracy is not enough. Only finding accuracy is not enough always. So the reason why metrics like SSIM, PSNR, and some of the other metrics we are going to use to evaluate especially image processing tasks. So SSIM, structural similarity index. So measure similarity based on luminance, contrast, and structure. These metrics ranges from 0 to 1. So 1 for identical images. You can say it is more aligned with human visual perception. Then the other metric is peak signal to noise ratio. So just I want to stress once again here, SSIM, PSNR, these metrics nowadays quantum machine learning. Most of the research is going on by applying this quantum machine learning. So if you apply this quantum machine learning on image data set especially, these metrics you need to find. Again, to get good research outcome, good research paper. So PSNR, peak signal to noise ratio, measures reconstruction quality here. Higher PSNR is better image quality. Especially for image compression, image denoising, we are going to find this PSNR value. Next, one more technique is intersection over union. So this metric is used in segmentation and object detection. So measures overlap between predicted value and ground truth masks. The formula for IOU is prediction intersection ground truth by prediction union ground truth. Next, DICE score. So measures overlap between two sets of pixels. It is similar to FL score of classification metric. The values ranges from 0 to 1. So common in medical imaging segmentation. Applications like brain tumor segmentation data sets, we are going to find this DICE score. So this is about performance evaluation metrics. So in performance evaluation metrics, especially I have explained 3 types of metrics. The metrics used in classification tasks, classification performance evaluation metrics. Names of the metrics are accuracy, precision, recall, F1 score, and AUC value. Next, the metrics related to regression, especially error values, MBIE, MSE, root mean square error, and also R square error. And the third one is image evaluation metrics. So metrics like SSIM, PSNR value, DICE score. So these are some of the important metrics need to be found when you apply image processing models. Just 1 minute. After understanding these challenges and limitations, so now I'm going to explain hands-on session by implementing some models on data sets. Can one of you acknowledge in the chat box? Are you following? Is my lecture is okay? Maybe little more theory is included. So keeping in view of covering a lot of concepts, foundations of machine learning, I have included most of the concepts. I hope you are following. Yes. Thank you for your acknowledgement. Thank you. Thank you. So, moving to the next concept, that are major challenges of classical ML techniques and some of the limitations of these ML techniques. So, it requires manual feature engineering. Already I have discussed. Feature engineering concept I have discussed, model optimization I have discussed, right? Everywhere user intervention is there, manual feature engineering. It is not going to learn itself automatically. That is one of the major challenges. So classical ML models like SVM, KNN, decision trees, Navy Bayes cannot directly understand raw data. Human experts must manually extract all these features. Texture features, statistical features, edge shape descriptors, domain specific signals, some of the examples I have included. So performance heavily depends on human intuition, not automatic learning. This is one of the challenge. Next, scaling issues with large data sets. Again, the known factor. Nowadays, we are going to use deep learning techniques. If the data set is large, then by applying ML, getting the results very difficult. That's why we need to move to the other technique called deep learning. So algorithms like these, the classical ML algorithms, will become slow when you work with large data sets. Training complexity grows non-linearly, like order of n square or n cube. If you increase the data set size, then the time complexity also increases. The other challenge is not suitable for raw images. So raw pixels directly if you give, these ML unable to understand and give results, good results. So need manual conversion again. You need to apply features like techniques like HOG, LBB, etc. PCA. Next, limited performance with huge data. So these are the major challenges faced by the classical ML techniques. And coming to the limitations, so less accurate than deep learning for images, especially when you work with image data set. ML techniques accuracy is little less compared to deep learning. Of course, deep learning is the advancement of the machine learning. That is the reason for that. But still there is a scope to improve classical ML technique performance. That's why I have included these challenges and limitations here. So these DL models automatically learn, whereas ML models user intervention, programmer intervention, researcher intervention is mandatory. High dependency on feature quality. So the model is only as good as the features extracted. If you are able to extract good features, then the model is good. If feature engineering, if you fail in feature engineering, again, it is going to fail the model. Poorly engineered performances, engineered features performance leads to bad performance. So it requires domain knowledge, expertise in feature principles, trial and error, tuning to overcome from this. So we are here technical. The major researchers are technical graduates. Suppose they are working on, say for example, bioinformatics. So the data may not understood the technical grade. Then the domain knowledge experts help you need to take. Say for example, doctors, experts you need to take the help so that you are going to get the good features. If you are able to retrieve good features, then you are going to achieve good results. Even coming to hierarchical features also. So these classical machine learning models I can say failure in understanding hierarchical features. Whereas deep learning we are going to use for these types of data sets. So before going to hands-on session, so I have included few research papers, literature papers. These are very important. Those who really want to do research on classical ML techniques by applying this classical ML on lot of real-time data sets. So these papers are very, very helpful. So very recent, 25, 24 papers only I have included. So that means with this, you have to understand that still lot of researchers are working with classical ML techniques. Classical ML techniques, they are going to apply to different data sets. Especially nowadays, the trend is multidisciplinary data set. So you need to select different data. Say for example, physics. You can apply the data sets related to physics, these machine learning techniques. The data sets related to chemistry you can apply. The data sets related to electrical engineering you can apply. So like this, multidisciplinary data set, if you are able to identify, definitely you are going to develop an innovative project by using these classical ML techniques. And you are going to present a quality publication as well. So the first paper here, brain tumor detection and classification using a hybrid CNN SVM based on fuzzy weighting and transit search optimization technique. So the key highlights of this paper includes here. They're going to develop hybrid FCNL plus SVM model 3D and also with fuzzy weighting and optimization techniques for classifying these brain tumors. These research paper worked with MRI data. So it shows how combining classical ML with deep feature extraction can reduce complexity yet achieve high accuracy, greater than 95%, on real medical MRI data. So it is very useful to show hybrid ML-DL combination. So classical ML with deep learning techniques, they are going to achieve good results. Then next paper, performance comparison of CNN and SVM algorithms in human face classification. So all these examples I have included in the PPT also, brain tumor detection, bioinformatics example. Now this is human face classification. So the key highlights of these papers include direct comparison between CNN and SVM. The popular classical ML models they have compared for face classification. Especially the face is stress face or non-stress face facial expressions. Given an input a face, whether that particular face is in stress or without stress, the application shows empirical strengths and limitations. So CNN outperformed SVM in this case with this data set, and it also has some limitations. So definitely the interested researchers may take this problem and they can try to solve these limitations. Similarly, these are the papers related to classical ML models. So a performance evaluation of random forest, ANN, SVM to predict spatio-temporal land use, land cover, LULC changes. Again, these researchers also compares the traditional ML models only, SVM, ANN, random forest. See, different researchers applying on different data sets. Previously, I said brain tumor, bioinformatics. Next, human face classification, stress and non-stress. Then, spatio-temporal, land use, land cover application. Next, computer vision applications also we are going to apply these classical ML techniques. So this is a survey paper, again useful for you, for the researchers. They used image classification, object detection, video segmentation, etc. They also discusses the challenges and future CNN research directions for getting good results. And one more one, review of CNN applications in smart agriculture using multimodal data. So like this, if you select multidisciplinary data sets, then still there is a lot of scope to get good results and to get good publication. So now we are moving to scikit-learn hands-on session. So before going to hands-on session, first let me quickly walk through what is scikit-learn, and in the PPT I have included the screenshots of the code snippets. I have executed the Google Colab notebook, some of the models. Those models now I am going to show you. So till now, if anybody have any queries, you may send in the chat box, or you may enter just for 2 to 3 minutes, so that we'll move to the next phase, that is hands-on session. Let me know if you have any queries. Okay, even physics faculty is also there. And from physics, it is difficult for me to follow. So I will share my PPT. You need to once again go through it, and real-time case studies. Now I will try to explain by showing some sample cases. Try to understand. While execution, if you have any doubts, you can ask. Image processing and ML are clear for faculties. Thank you. Any more? Right. So what is this scikit-learn actually? So scikit-learn is the most popular machine learning library for classical ML techniques. It provides many functions for pre-processing, model training, evaluation, optimization, etc. So using this scikit-learn environment, we can apply all these classification tasks, we can perform regression tasks, we can perform clustering, model selection, pre-processing, and it is well documented and easy to use. And especially this scikit-learn is built on 3 packages. NumPy, which deals with numerical operations. SciPy, which deals with scientific computing. And also the most popular Matplotlib, which is majorly useful for visualization. So this scikit-learn built on these 3 packages: NumPy, SciPy, and Matplotlib. So whatever the ML model you are going to apply on whatever the data set, the common workflow is like this. Most popular and most common workflow is this. So you need to load the data set first. So actually scikit-learn includes some data sets. Already inbuilt data sets are available. So in my explanation, I have used those data set, the most popular data set like Iris data set. Even the downloaded data sets also you can simply upload to the environment and you can use. After loading the data set, the first next step is pre-process the data. So in pre-processing, you're going to perform, say, for example, cleaning, missing values, duplicate values, and you need to perform encoding and scaling. So according to the data set, first you need to read and understand the data set. After that, you need to apply proper pre-processing techniques on it. After pre-processing, the next step is split the data for training and testing. So generally, usually 80:20, 80:2. 80:20 is the common split train and test. Most of the researchers follow, and sometimes some of the researchers will go for 70:30 or 75:25. So minimum 20% you have to use. Then after splitting the data into train and test, then we need to select the model and train the model, fit the model using the training data. Then you need to evaluate the model with the training data as well as testing data. That is more important. So in the evaluation of the model, you need to identify the metrics. Based on the task you performed, you need to identify the particular metrics and you need to go for using visualizations. So let us say if you are performing classification, then what are the metrics you need to evaluate? Accuracy, precision, recall, FR score, AUC value. If you are performing regression, then you need to evaluate error values, different errors. MSE, RMSE, R-square value. Image processing technique. Then you need to go with the metrics related to image processing. So namely, we have SSIM, PSNR, etc. DICE score. Right? Finally, we need to optimize the model. In optimized model, not only hyperparameter tuning, we are going to use different other techniques like regularization, L1, L2 regularization, cross validation. So different techniques we use for optimization model. So this is the typical ML workflow. Whatever the ML classification ML technique you are using, the most popular, most common steps involved in applying and getting the results are these. So these are the code snippets. So first we need to quickly 1-2 minutes I will quickly rewind this and then I will run and show the results. So first we need to import the packages, required packages. So here NumPy, Pandas, Matplotlib, scikit-learn packages. Next, dataset overview and helper. We need to load the dataset and we need to understand the dataset. I will execute anyway, that's why I'm moving forward quickly. Then preparing iris dataset and scaling the iris dataset. So I'm using here scalar function, standard scalar. Then I have applied logistic regression first. Logistic regression. So all are predefined models. Logistic regression model exists. Like that, all classical model code is available. You can use predefined model effectively. Then I have applied SVM, the popular SVM, and I have used the kernel here, RBF kernel. You can, this code I will share, you can change the parameters and test the results. Next, I have applied KNN on iris dataset only. Then I have applied random forest. All these are classification models, classical ML classification models. Then I have developed confusion matrix. Some disturbance. Okay. Then I have found AUC. Then for the different data, California housing data, I have applied this regression. For applying regression, I have preparing the data set, California data set. On this California data set, California housing data set, I have applied linear regression, decision tree regression, random forest regression. Then I have applied grid search optimization technique. then pipelining and cross-validation. So these are I have performed. So just move to the hands-on session. I have applied grid search optimization technique. Is it possible to send these Google Colab files? So these are in the Meet performed. So that interested participants can work with this file directly. It won't take much time. Yeah, anyway. So just let me execute, try to follow. So first we need to import all the required packages. So like NumPy, I have imported as NP. Similarly, Pandas, I am using the naming conventions. For who don't know coding, these are the names NP, PD. We are going to give shortcut names. For Matplotlib, we are going to use Plat. So like this, whatever the required packages for our task, we need to import first. So just quickly, I'm running again. Or if you want to run by opening another new file, I will do that. So I have go to my drive. Here I am opening a new Google Colab notebook. Right click, more, Google Collaboratory. For those who want to work from scratch, I'm telling now. So now you can rename your file here. Say for example, I am renaming it as demo4. So I have explained this code. So simply I'm copying this code and executing in new Collaborate. First importing. So libraries imported successfully. Then you need to select next code. So then I have performed dataset overview and helper. So show dataset information. So which dataset I have used? The iris dataset. Feature shape of X shape value is how much, target shape Y shape value is how much. I'm going to trying to find it. So along with iris, I also try to understand wine dataset, breast cancer dataset, digits dataset, California dataset. All these datasets are available in scikit-learn platform. If any of the datasets not available in scikit-learn platform, real datasets if you want to use, then you need to upload those downloaded datasets into this Google Colab platform and you need to apply these techniques. See, I got here iris features 150 and 4. So X shape is having 150 values with 4 columns. Whereas target shape is having 150 values classified into, say, for example, 0, 1, 2 or 0, 1. Each value is having either 0 or 1, only single dimensional array, I can say. So the feature names are sepal length, sepal width, like this. Similarly, wine dataset information, breast cancer dataset information. I wrote the logic to understand these dataset information. For that purpose, show dataset information function I am using. So this is how we need to understand the dataset. Then after understanding the dataset, then prepare iris and scale the iris. So iris dataset, I want to perform some applications, some models I want to apply in a iris dataset. So I have split the data. So train consists 120 values, test consists 30 values. Test size 0.2. That means I have followed 80:20%. You can change here the parameter value to 30 or 25. And you can test the results for different train and test splitting. Next, I have applied logistic regression. So this is the logic for logistic regression. So I found accuracy I got for iris dataset 93.33 accuracy, 0.93. And these are the other evaluation metrics: precision values, recall values, F1 score, support value. Then after getting these values, I have applied SVM model on the same iris dataset. For logistic regression accuracy, I got 93, whereas for SVM, I got accuracy 96. Similarly, like this, we need to apply different models. So now KNN model. For KNN, I got the accuracy 93. So most of the ML codes will give result very quickly, especially with this numerical data. When you are applying with image data, then time taking is little more. And it is also based on the size of the data as discussed. Next, I have applied random forest. Random forest accuracy is 0.9. So like this, you can apply different models on single data set, same data set, and you can, this type of research can be helpful in comparing the results. After applying random forest, then I have generated confusion matrix. So confusion matrix consists what values? The terminology is very important. You need to remember true positives, true negatives, false positives, false negatives. And it is the base. This confusion matrix is base for getting all classification metrics: accuracy, precision, recall, F1. All these formulas are based on confusion matrix values only. True positive, true negative, false positive, false negative. This is the confusion matrix generated. Then I found ROC AUC value. So I explained if this value is close to 1, then it is like accuracy. We need to optimize it. If it is close to 1, close to 100, then that model is good. So AUC value 0.99. For class 0, I got 1, whereas for class 1, I got 0.99. So this is how we need to write small coding snippets on real-time dataset and get the results. And we need to analyze and understand the results. That is for classification. Next, for regression dataset preparation, I have used this code. Train shape is this. Next, linear regression I have applied. Already I have discussed when you apply regression, you need to find the error values. So I have write the logic to get the error values. Then decision tree regressor, another popular regression technique. So different values I am getting for different models. So that in comparison, we are going to get what is the best model. Next, random forest regressor. It may take just 1 to 2 minutes time only. Then I have given one example for grid search and pipelining and cross validation. So we can understand grid search, hyperparameter tuning by executing this small code snippet. See, best parameters, C value 10, gamma value 0.01, kernel value RBF. Best CV score is 0.975. Grid search. Then in this way we can work with classical ML models. So nowadays you have lot of resources, open resources available, lot of AI tools are available. Simply you need to understand, I can say, prompt engineering. So if you prompt in a good way, you are going to get the coding directly with the help of AI. AI generated code not always suggested to use directly. So AI help you can take, and you need to understand the code and you need to optimize it. You need to do little changes to get good results. So this is how we can work with classical ML models. Some of the examples I have shown here, and if any participants are really interested, I will share these Google Collaborator files with you so that these are helpful for practice. You can understand these basics and you can apply same models or other models on your selected data set. So this is how we need to execute in Google Colab environment. So everyone can easily understand and easily access this Google environment. And it is, if you execute in Google Colab environment, there is a flexibility that from wherever you are, you can able to access. So I always use this Google Colab platform for research, and of course it is going to provide little resources. Here it is available, RAM and disk. If any researchers are really interested, you can go for purchasing higher end configuration so that you are going to get good results in quick time based upon your research problem statement. Or else you can install a normal Jupyter Anaconda and you can open Jupyter Notebook and you can run these applications in your own system as well, own personal computer as well. So this is hands-on session related to applying classical machine learning to the real-time data sets. I hope you gain some knowledge, some insights from this. So before closing, let me quickly move to the last topic of the day, that is introduction to quantum machine learning. So before going to this introduction, again, let me rewind quickly till now whatever the concepts I have explained. Starting from what is machine learning, then classification of machine learning, supervised machine learning, unsupervised machine learning, and reinforcement learning. Then we understood, after understanding this classification, then immediately I have explained the classical ML techniques, especially 3 techniques I have explained: support vector machines, artificial neural networks, and convolution neural networks. And support vector machines, we have 2 categories: linear and non-linear. Non-linear, especially whenever you are using non-linear data sets, then the main point I said is converting the given data points into higher dimensional data. If the given data points as it is you take, it is not possible to separate by using linear SVM. In such cases, convert the given input into higher dimensional data so that there is a chance to draw an hyperplane which can separate the data points, which can use for classification purpose. Then after that, I have explained artificial neural networks, the architecture of artificial neural networks, then activation function and backpropagation as the key concepts in ANN, then followed by its application, then the basic convolution neural networks architecture I have explained, and you can modify the CNN by using your own number of layers, and by doing that modification, it's possible to get a good model for particular data set. So different data sets may need different types of convolution neural networks. Then I have explained the very important concept, feature extraction, and what are the different feature extraction techniques are there, followed by model optimization techniques I have explained. Then challenges and limitations of the classical machine learning models. Then I have taken a little hands-on session. I have explained few models on 2 different types of data sets. So moving to the next session, that is introduction to quantum learning. So this is on high demand topic current nowadays. So classical ML has limitations in optimization and high dimensional data handling, that you know, right? So quantum ML combines the strengths of quantum computing with machine learning to solve complex problems more efficiently. So that is the key point here. So quantum machine learning means it is a combination of quantum computing plus machine learning. So in normal machine learning, we never use the concepts, the terminology like qubits. Whereas in QML, in quantum computing, we are going to use qubits. So with the help of qubits plus classical machine learning, definitely it is possible to achieve good results. Of course, still nowadays we are using classical systems. Quantum machines are not in existence, but lot of research is going on quantum machines. Once quantum machine come, so all the tasks can be done like in seconds or fraction of seconds. That much impact is going to create quantum machines. So as a researchers, we need to understand the importance of quantum machine learning. So from classical ML to quantum ML. Combines quantum computing principles with machine learning. Next, computes using qubits instead of bits, just now I said. Leverages superposition and entanglement. I hope in yesterday's session, other resource person explained about this superposition as well as entanglements, as well as qubits and some other algorithms. So parallelism is achieved. So I can give simple example for this quantum applications. So let us assume in your office you are having 10 desks. you want to search a key is present in which disk. Normal search if you use, you need to open linearly, disk by disk. Disk 1, is it key is present or not? Disk 2, key is present or not, like this. It takes a lot of time. Whereas quantum search, if you apply, quantum search how it works means, all 10 disks will be open at a time. So that within 1 second, within 1 minute, within fraction of time, you're going to find in what disk the key is available. Like that, the quantum computing applications are going to be much faster, much faster. So why QML is important? Efficient for high dimensional features, spaces, advantage for optimization and search problems. Just now I have given a sample example. And useful in lot of multidisciplinary domains. Quantum chemistry, quantum physics, quantum material science. Relevant in cryptography, quantum key distribution, even cyber security also. Even federated learning also, we can combine quantum computing applications with federated learning. So like this, each and every topic related to data science, machine learning, deep learning, all these concepts going to combine with quantum computing applications and going to get a super models with the help of merging this quantum computing as well as machine learning concepts. What is the realistic status of current QML technique? So quantum computers are still in NISQ era, noisy small qubit numbers. So qubits, a lot of research is going on. If the qubits number increases, then that much faster the performance you will get. Yet not ready to replace classical ML. Quantum machines are not ready, but developing stage. So hybrid quantum classical approaches are practical today. Lot of software tools are available. Like using your Google Colab platform, how I have executed. Similarly, you can implement Qiskit, PennyLane, SciQ packages. These packages are related to applications of quantum computing, especially used for quantum machine learning application. So QML research directions. So what are the current research opportunities we have in this area? So we can use quantum classifiers, QSVM, quantum perceptrons, we can use quantum neural networks, QNS, we can use variational quantum circuits, quantum encoders, we can use quantum autoencoders, we can use. So for each and every application, we can combine the quantum technology to get good results. So even hybrid quantum GANs are used, especially in bioinformatics, like brain tumor detection or brain tumor segmentation techniques. So again, how I have included the latest research for classical ML. Similarly, I have included few papers information about current research, what going on using quantum machine learning, QML latest research. So the key highlights I have mentioned here. So for the first paper, hybrid convolutional neural networks optimization, combining quantum plus CNN. So it is published in 2025. So it investigates hybrid convolutional neural networks, QCNNs, blending quantum circuits plus convolutional neural networks. And this gets some optimization results. This connects